Okay, good morning class. So we're trying to wrap up with geometry. Hopefully we can do it today so that we can move on to trigonometry. We are behind, as I indicated already. However, we have started a topic when we are experiencing load shedding. We are doing okay. It is a term 3 topic. Okay, so you won't be tested now. Alright. But don't use that as an excuse not to do the work that is assigned to you for that day. Is there any problems that you're experiencing at this point with financial maths so far? Nothing yet. If you have a problem, you just bring it to me. At the end of the lesson, I'll try and explain to you. Okay. Otherwise, if there's a problem with the video, let me know as well, so that I can either redo the video or I can make a note, whatever. Okay. So we're on worksheet 10H. Is that correct? Number 1. Okay, I'll take this one out. So you have to do the odd and even numbers, no? Is that correct? Yeah. So what I'm going to do is I'm going to send you at the end of today's lesson a written memo of the whole exercise. Okay, that was done. I'll send you that to the group. Okay, so that you can just check whatever even numbers that you had a problem with. I don't think we'll get even to that today. Okay, I don't even think we'll get through all of these sums today, because I don't want to also rush it, man. You understand? And then we lose vital information from these examples for riders. Okay, so at this point, people, we are told if C1 is equal to C2 is equal to D1, which is equal to D2. So I'm going to mark that all with circles. C1, D1, and so on. Prove that B1 is equal to E1. B1 is equal to E1. People, from here, if we let this whole story, C1 equals, sorry, this is right here, let C1 equals C2 equals D1 equals D2 equals, and we assign X to it, then this is what it's going to look like. Not so? So now we can see, okay, what is B1 equal to? B1? What is B1 equal to? B1 is equal to C, the whole angle C plus D2. Why? Exterior angle is equal to sum of two interior opposites. Not so? You will agree with that? So we're saying B1 is equal to 2x plus x, which is 3x, so I could have just written 3x. Why? Because that's exterior angle of triangle. Dot, dot, dot. It's the exterior angle of BCD. Okay. So this angle now is 3x. What is angle E equal to? E1. Same story. Not so? E1 is also equal to 3x. Why? Exterior angle of triangle, dot, dot, dot. And that means you say exterior angle of triangle equal to the sum of the two interior opposite. And that's the exterior angle of triangle ECD. You don't have to write that triangle ECD in the previous reason of triangle DCB. You don't have to write it. So what do you notice now? Therefore, angle B1 has to be equal to E1, which is equal to x. Okay, and they have proven what they wanted there. Any confusion here? What got you down in this question? Yes? Sorry? D1 equal x. Yes? But remember, you're saying C1 is equal to D1 is equal to x and C1 is equal to y. You see in the opening statement there, they say if C1 is equal to C2 equals D1 equal to D. That means to say all of it is the same already. You understand? So you should have had the same variable throughout. Okay. Let's look at H. In H you are given A1 equals A2. Angle A1 is equal to A2. This also means that BD is bisecting. Sorry, AB is bisecting. This line here is bisecting BAC. That means to say that that line AD is cutting that angle BAC in half. Okay, instead of saying that, they could have said it's bisecting that angle. Okay? So in other words, that angle is equal to that angle. Then we are told that C1 is equal to C2. That angle is equal to that. Now you see, then I could have said let A1 equal to X, A2 equal to X as well. Then C1 would have been equal to Y and C2 is equal to Y. Why? Because they are different entities. They are different sizes. You understand? And also, FC is bisecting angle ACB, if needed. Another way they could have said the same thing. Then they tell that CF is parallel to ED. So if those lines are parallel, what do we know? Alternate angles are equal, corresponding angles are equal, and co-interior angles are supplementary. So this angle will be equal to that angle, corresponding angles. Can you see that? This angle is equal to that angle, corresponding, and so on and so on and so on. Okay? So that is also an X here, and there's different angles here. Then we are told that angle B is 80 degrees, and angle DCA, this angle here is 50 degrees. Okay? They want you to calculate G1, which is this angle here. Okay? Yes? Did I make a mistake? Yes? Where's the mistake? D, C, A. D, there's D. C, oops, that's my mistake. Yeah, absolutely correct. D, C, A. So it's this angle is 50. Okay. So each angle there is going to be 25. So that is not there, so 25 here. G1. I really know what about G1. So you got the exterior angle, you got 25 corresponding. Let's just take a square. Let's go again. So in triangle we say that that angle is equal to that. That angle is equal to that there. These lines are parallel. Okay. So 8. And degrees 80. So what angle is 50. So angle G1 is the same as angle D2. Not so. G1 the same as D2. Why? Corresponding angles. So let's see what we can calculate. Okay. So what you can calculate from the beginning, we can say that C1 is equal to C2, which is equal to 25. Why? Because that was given to us. That C1 is equal to C2. Not so? You all agree with that? That is 25. I can't see it immediately here. So there might be that I'm calculating an angle unnecessary. Okay, but as I say, I can't see it immediately. Okay? Okay, there I can see. G1 is the exterior angle. Can you see it? G1 is the exterior angle of ACG. Can you see that, people? So G1, I got that 25 degrees here. Now I need A2. Then I've done the job. Not so? So we have 25 there. Then we know that A1 is equal to A2. That was given to us. So we know that 80 degrees plus the whole angle A, which is BAC. Well, I could have named it twice angle A2. But just keep it simple for now. Plus the whole angle C. What's the size of the whole angle C? 50 is equal to 180. Why? Sum of triangles, and it's triangle ABC. Okay? So that is going to give you BAC to be 50 degrees. Not so? Which means to say that A1, so the whole angle is 50 degrees. So A1 is going to be 25 and A2 is 25. So A1 is equal to A2, which is equal to 25 degrees. The reason? Given that A1 is equal to A2. Okay. Now it's enough to conclude that angle G1 is equal to A2 plus C1, which is 25 plus 25, which is 50 degrees. Why? So it's the exterior angle of triangle, and it's the exterior angle of triangle GAC. That's probably behind the calculator there. So remove the calculator. Okay. So that is A, so that I'm going to put 50 degrees here. Let's look at B. B the one D2. But we already indicated that C as G1 and D2 is already equal. Why? Why is D2 50 degrees? Corresponding angles. With FG or FC being parallel to ED. Again, when you use corresponding alternate criteria, you must say the lines that are parallel. So here's 50 degrees here. E2. So for C is E2. E2 is this angle here. You see E2 is the exterior angle of triangle ADE. Can you see that, people? So E2 is equal to 50 degrees plus 25 degrees, which is 75 degrees, and the reason here is exterior angle of triangle, dot dot dot. That means to say is the exterior angle of triangle equal the sum of the two interior opposite, and it's the exterior angle of triangle EDA. Okay, any confusion here? Alright. Let's do I. In I, number 1, we are asked to prove that AD is equal to ED. Okay, so how are we going to do that? By proving congruency. So if you look at the length that they're looking at is AE, if I have to form a triangle, it's going to be that one there, and this triangle there, of course. Okay? So what can we say already from there? Those angles are equal, those sides are equal. What else can be said? A? E1 equal to E3. Why? And then the job is done. So let's just set it up. We say in triangle AEB, try and get the order right from the beginning, and triangle DEC. Okay? We're going to firstly say that AB is equal to CD. Why? It was given equal. Then angle B is equal to angle C, which is equal to 90. Why? Also given. Then E1 is equal to E3. Why? It's vertically opposite. So therefore, triangle AED, is congruent to triangle DEC. Why? Angle, side. Then we can conclude, therefore, AE is equal to ED. Why? Because triangle AGB, no? Or AEB, sorry, is congruent to triangle DE. Okay. That was 10I, number 1. Let's look at number 3. You are required to prove that D2 is equal to E2 if AB is equal to AC and BD is equal to EC. So how are we going to prove that D2 is equal to E2? If those angles were equal, what can be concluded? I hope that's a maths book you're taking out, no? Oh, and nice, you're putting it back. Nice. Why you got so many books on your table? Oh. People, if D2 was equal to E2, what could you have concluded? That the line AD would have been equal to line AE. AD is equal to the line AE. Why? Angles opposite equal sides. Now to prove that those angles are equal, we now prove that the sides AD is equal to AE. Makes sense? Right, how are we going to do that? By using congruency. Okay. So of course it's going to be those two triangles here because of the information that you have. But we have two sides. What else is equal? What else is equal here in those two triangles highlighted there? Angle B is equal to angle C. Why? Angles opposite equal sides. Can you see that? Okay. So let's go with that. We name the triangles we're working in. So we say in triangle ABD and triangle ACE. What can we say? That AB is equal to AC. Why? That was given to us. Then BD is equal to EC. Why? Given. Then we're going to say that angle B has to be equal to angle C. Why? Angles opposite equal sides. Therefore, triangle ABD is congruent to triangle AC. Why? Side angle side. For this one, it must be the included angle. Is this the included angle? Yes. So what can we conclude here? Therefore, AD is equal to AE. Why? Because triangle ABD is congruent to triangle ACE. So now these lengths are equal. Therefore, E2 has to be equal to angle D2. Why? Because it's sides, angles opposite the sides are equally. So it's angles opposite equal sides. Okay? Make sense? Nice. Let's carry on with the lives. J, 10J. Number 1. Sorry? Should have. I told you must move on. Didn't I? Yes. Didn't tell you. So I need to finish this chapter. So angle, so you didn't do this. Okay. So what I'm going to do is I'm going to give you a deadline now for this year, because we are just spending way too much time on this. We are on lesson 100 already, I think. What lesson are we on now? Grade 10. Euclidean geometry. Are we only on lesson 6 now? Is that right? They don't feel right. Are we on lesson 6 now? Okay, nobody's talking to me. So what I want you guys to do is worksheet for homework for Monday. Okay? I want you guys to do 10J, the whole of 10J, and the whole of 10K. Okay? Then what I'm going to do is I'm going to do NL. This is for Monday, not tomorrow, for Monday. And M. Is that too much? Yes, okay. Till L. No? I'm going to send you the memo. So if you have a problem, just refer to the memo. Again on Monday, we're just going to do the odd numbers. Is that okay?
Yeah.
Yes, Michael.
Does all the thingies, all the...
Diagrams?
No.
No, yes. All the?
When you're calculating
Calculate, yes.
to answer, to find the answer in parallelogram,
Yes.
does the thingies add up to 360?
The interior angles.
Yeah.
Yes. Any quadrilateral, any four-sided figure enclosed by edges, quadrilateral, no? The interior angles will always add up to 360. Okay. Alright, you guys got it? So you got those three worksheets to do for? Monday. Alright. Next heading, trigonometry. I'm going to stop this video here and start our trigonometry as well. Okay.